All right, line A1, learn test number 16. We're going to take a look at solving problems involving inductive reactance. And we're not actually going to go through the bulk of the problems inside of this video. I hate to break it to you, but your book covers most of those problems quite well for you. What we're here to talk about is just this chart that you see in front of you. And a couple of things that I want to go and lay out on that chart. First of all, we should see that all three columns are going to go and be very, very, very similar across, the individual types of formulas that we're looking at. Let's just examine the very top one over here. We see that I is equal to E over R. I see that IR is equal to ER over R. And I see that IX is equal to EX over top of X. You should instantly recognize these as being the exact same formula, just written in a bunch of different manners. First one over here talks about a DC component. If I've got a DC component, I find the current by taking the volts over top of the resistance. That's straight up Ohm's law. If I've got AC resistance, I can take the volts that are over top of that resistor, divide it by the resistance, and it's going to go and tell me about the current that I'm going to go and have through that resistor. And it would not matter whether I'm going to be looking at a series circuit or whether I'd be looking at a parallel circuit. Let's say that I had 60 amps that was being dropped out of the 120. Sorry, not 60 amps, but 60 volts. If I was dropping 60 volts over top of a 10 ohm resistor over here, what I would do is I would take the volts that's over top of the resistor, so the ER, that would be this 60 volts, and I would go and take this value of resistance, the 10 ohms that I'm going to go and have, and then I would use that to develop the amount of current that I would have going through that resistor alone. So we see that the subscripts start playing into this now, where the subscripts are going to be identified as being measurements taken for that specific component. So when we're dealing with our resistors, we see this R subscript. What we see in the final column over here, and it's a new column for us, but it's still, the same old, is reactance. And it's identified with an X. Now, we have talked about the fact that inductive reactance is identified as being our XL. We are going to go and find the current through any sort of inductive component the exact same way. Take this and substitute in an inductor. If I've got an inductor inside of that circuit, I would be able to go and find my current that's going through that inductive component. So the IX, whatever this is going to be, would be whatever my voltage is that's being dropped across this inductor, divided by the actual inductive reactance, the XL that I would have with this inductor. And we're going to have to go and find our XL as being XL is equal to 2 pi FL that we will use. All of these formulas that are in this column, the reactance column over here, are going to go and use X's. We are going to see a repetition of this column when we go into our capacitance. So for now, just know that anytime that there's an X, you can either subscript that as being XL or XC, depending upon the component that it is that you are looking at. The center section of this one is going to deal with a bunch of power formulas. So the top part over here is all just Ohm's law. The next part over here is going to go and be Watt's law. It's all dealing with power. Power is E times I. If I've got resistance, my power is going to be my E times my I, my line volts times my line current times my cos theta. We're going to cover that later on when we start dealing with power factor, but that's really where we're looking at what we have got for a Z versus an X versus an R. So it's a little bit ahead, so don't stress too much about where this cos theta comes from right now. Work with these other formulas that we're going to have inside of here. Same with this one over here for my VARs. VARs is a form of reactive power, so I'm just going to do Watt's law for reactance inside of these columns over here. The sine theta that we are going to go and have over here is once again just a little bit of a jump further ahead. Until we have figured out what power factor is, some of these are just not quite usable for us yet at this point. They are not going to go and ask you any questions to do with these. They're just going to ask you straight up Ohm's law-ish type of questions where you're going to have to go and deal with XLs, where you're going to have to go and deal with Rs. There's even one where you're going to have to go and create the Q of a coil itself. So work with these ones out of here. Get familiar with just the basic operations of them. And then past that, you should be good to go. It's a pretty straightforward learning test, this number 16. I'll leave you to that. We will go and pick up again inside of the behavior of AC capacitors next.